All right, super quick review of polynomials and the things that I'll be looking for there. One thing that we did was the leading coefficient test, which helps us know about the end behavior, whether we go up as we move to the right or down as we move to the right, and as we go up as we move to the left or down. And what happens in between can be, we can help determine that by finding our zeros. So let's say that somebody has done the work for me already, and I know I have an x plus 1 squared. I know I have an x minus 2, and I know I have an x plus 4 to the third. Right. So the types of things that I need to see on your graph for full credit, I need to see all of the x-intercepts of that graph. I need you to label all of the y-intercepts, which at most will be 1. There will be 1 if it's a polynomial. Okay, it can't be more than 1 or it won't be a function. I need you to know what to do with the multiplicities. So and also make sure your end behavior is right. Okay, if your y-intercept is some crazy number, I know it's like -36 on the homework, 12 for the other one. It doesn't have to be for scale. You can just put a dot and say here is 0, 12. I need you to label it so I know that you know how high or low the graph goes, but it doesn't have to be to scale around the other things. So to determine end behavior, we need to look at the leading coefficient and the leading term, the degree of the polynomial and the leading coefficient. So remember how we can cheat and just look at these first terms, x squared and x to the third. And if we put those together, we get 1 x to the 6th. Okay, and who cares what the rest of the stuff is? 1 being positive tells me my graph goes up as I move to the right. The 6 being an even number means both ends go in the same direction. So I know that the end behavior for my graph is I'm going to go up to the right and up to the left. If I want to find the y-intercepts of a graph, y-intercepts happen when x is equal to 0. So when x equals 0, I have 1 squared times 0 minus 2 times 0 plus 4 to the third. Okay, so 64 times -2 is -128. Okay, so once again, it does not have to be to scale. You just need to put a dot down here and say, here is 0, comma, -128. Okay. All right, can I copy and paste that? Hey, I can. All right, so the zeros are what happens, or are the x-intercepts. The x-intercepts happen when y is equal to 0. If I have the polynomial already factored, I just have to set each factor equal to 0 and solve for x. I also need to consider the multiplicities, meaning since x plus 1 was squared, that's multiplicity 2. Okay, to the first is multiplicity 1. To the third is multiplicity 3. That tells me what happens on my graph. Again, -1, 2, 3, 4. 1, 2, 3. Okay. My graph is going to intersect the x-axis here, and here, and here. Okay, but the multiplicities tell me what happens when I get there, whether I'm going to cut straight through it, whether I'm going to bounce off of it, or whether I'm going to wiggle. Okay, multiplicity 3, and that's the official word your book uses. It's going to wiggle. Wiggle means it kind of gets flatter, not quite that flat probably, but as it comes down, it kind of flattens out. Different from multiplicity 1, where we cut straight through, or multiplicity 2, where we just bounce off. Okay. So I know that my graph goes up to the left, it goes up to the right. I know at -1, I'm going to bounce. I know at +2, I'm going to cut through. I don't draw right to left very well. I'm going to bounce. And then I didn't draw this piece very nicely, so I'm going to get rid of him. And this one, when it wiggles, it needs to just be a little bit flatter like that. Okay. Different than cutting straight through like we did right here. Now, in real life, this graph might come way down here. Okay? It might just barely come around. I don't really know. I don't really care. Okay, but the things that I need to see on your graph, I need you to go through this point, that point, that point. Okay, I need you to label your y-intercept. I need you to start from above. I need you to bounce off of -1. I need you to cut through, wiggling at -4. Okay, cut through at 2. Now the domain of this function, it's a polynomial. The domain is all real numbers. Okay. Now for the range, my pen won't write. Without more information, without a lot more computerized or other calculus-based assistance, it'd be tricky to find where the lowest point is. Okay, but the lowest point would be somewhere, some finite number, and then the highest point would be infinity. Okay. So again, the range you would not be expected to find on a graph like this because it's a little farther outside the scope of what we've done. But if you have questions about polynomials, some of you were close on your homework, but not all the way there. So give me a shout if you need me.